Today we're looking at parallel and perpendicular lines. Parallel and perpendicular lines have a particular relationship with one another, not parallel to perpendicular, but parallel lines have the same slope. And with perpendicular lines, if you take their slopes and you multiply them, you get -1. So another way to think of that, multiplying together and getting -1, is that the slopes are negative reciprocals. Up here on your notes, there is a reminder about the slope formulas that we looked at yesterday. The vertical change over the horizontal change is how you find slope. So looking at a few practice problems here, we have some linear equations that are in slope-intercept form. And so as a reminder, to find the slope when you've got a line in the equation of a line in slope-intercept form, you're just looking at the coefficient of the x. And that gives you your slope. So here's our coefficient of x here is 2. So for a parallel line, that would mean that a parallel line also has to have a slope of 2. And for the perpendicular line, the slope would have to be the negative reciprocal of that. So since this is a positive 2, the negative reciprocal would be negative, and then reciprocal just means you take you flip the fraction. So 2 flipped would be 1/2. So slope of a perpendicular line to this one would be -1/2. So for the next one here, our slope of the original line is -2/3. So any line that's parallel to that one would also have a slope of -2/3. And in order to be perpendicular, it has to have a negative reciprocal slope of that one. So since this one was negative, that means the slope of the perpendicular line would be positive. And then we flip the fraction also. So that would be +3/2. For this third one, the coefficient of the x is not listed explicitly. So that's understood that the slope there, the coefficient is a 1, which means the slope is 1. So the slope of any line parallel to this one would also be 1. And for a perpendicular line, it would be the opposite reciprocal of 1. So since 1 is positive, opposite would be negative. And the reciprocal of 1 would still be 1/1, which is 1. Alrighty, so now we're going to find parallel and perpendicular, or neither. Lines can be parallel or perpendicular, or they can be neither. For lines that are defined just by a couple of points that are on the line, which is typical how we define points in geometry. So there are a couple of fully worked out examples here for you. I'm not going to go over those with you. I'm going to let you try those. I'm going to come down to this one here where we're going to work on it together. So the first thing we're going to do is find the slope of the two lines that are defined here. Our first one is line AB. So I'm going to write that down. So line AB is the one that I'm doing the work for. So the first thing I want to do is copy down the coordinates of the points for A and for B. So that's given to me up here. So A is 0, 3, and B is 2, 4. So now I'm going to find the slope of this line. And to do that, I'm taking the difference of the y's, so y2 minus y1, and I'm dividing it by the difference of the x's, so x2 minus x1. Then I'm just doing those calculations. So 4 minus 3 is 1, 2 minus 0 is 0. So the slope of line AB is 1/2. Now I'll do the same for line CD. So we can compare the slopes of these two and determine whether the lines are parallel, perpendicular, or neither. So again, I'll start with writing down the coordinates of the points C and D. So C is 2, 1, and D is 8, 4. And then I'll find the slope of that one using this slope formula. So the difference of the y's, 4 minus 1 y2 minus y1. And then the difference of the x's, so that would be x2 minus x1, 8 minus 2. And then when I subtract there, so 4 minus 1 is 3, 8 minus 2 is 6. 3/6 is a fraction that can be reduced, so I'm going to go ahead and reduce it. Both the numerator and denominator are divisible by 3, so that gives me 1/2. And so next up, I need to analyze the relationship here. So I got the slope of the first one is 1/2. So the slope of AB, line AB, is 1/2. We'll say slope of AB is 1/2. The slope of CD is also 1/2. So the slope of AB is equal to the slope of CD. And the relationship between those, because the slopes are the same, is that the two lines are parallel. So I'm going to say line AB and line CD are parallel. Okay, we also have a graph here so that we can graph the 2 points that we were given for each of the lines and connect them. And then we can kind of see on the graph that the lines are in fact parallel. Parallel is easy to tell just at a glance. Perpendicular is a little bit harder to tell on a graph. The graph has to be perfectly square, and even then it's a little hard to see sometimes. Anyhow, so I'm going to say that this point over here is the origin, since all of my coordinates have positive values. I've got 0, 3, so I go up 3, put a point there. That's A. And then I've got 2, 4 for B, so over 2 and up 4. And then I'll connect those. I'm going to use a tool. I think I've got a line tool in here. Nope, apparently not. Okay, so I'll just freehand it. This was point B. And I connect them. When I draw lines on paper, by the way, I always use some kind of a straight edge, a ruler or an index card or an ID or something like that, just to make sure that my lines come out nice. Harder to do on a computer if you don't have the special tools to go along with it. Okay, next up I've got point C is at 2, 1. So 2, 1 is here. And point D is 8, 4, so that would be over 4, 5, 6, 7, 8, and up 1, 2, 3, 4. There's D. And again, I'm going to freehand it, so it's not going to be perfect, but hopefully it'll come out fairly decent. Okay, and so just at a glance, it looks like these two lines are parallel. Alrighty, so there's some guided practice problems here on the second page. I want you to work on those independently, so you're going to pause the video and try all 3 of the problems, and then come back and see how you did. For this first one, they give me a point, and then they give me the slope of the line that contains that point. So I'm going to start with that. 1, 2, 3, 1, 2. Here's my point. And the slope is 4, so in order to find another point that's on the line, I can use that slope. Remember, this is vertical change over horizontal change, so if I put a 1 underneath it, that gives me the vertical change is a positive 4. So from this point, I would go up 4. 1, 2, 3, 4. And the horizontal change is a positive 1, so a positive 1 change would be to the right 1. So that would give me another point. Now, if I wanted to, I could also develop some more points that are on this line by making both the numerator and the denominator of this fraction negative, because a negative divided by negative is still positive. So that means I could go back to my original point there, and instead of having a vertical change of +4, I'd have a vertical change of -4. So I go down 4. 1, 2, 3, 4. And the horizontal change, again, instead of being a +1, it would be a -1. So that would be to the left 1. So I could get more points that way if I need them. I could do that one more time actually on this grid, I think. So 1, 2, 3, 4, and 1. There we go. And then I connect the dots. And I'm putting arrows on the end of either side. I do want to kind of emphasize this a little bit. Lines go on forever, so just because we only have a little bit of a coordinate plane to work with there, that doesn't mean that the line stops. So you do need the arrows on the end. That indicates that the line continues in this pattern forever. Okay, for the next one, it says the line is going to pass through C, which is at -2, 5, and it's going to be parallel to LB, which contains these 2 points here, 2, 1 and -1, 4. So I'm going to go ahead and plot C. So -2, 5. So from the origin, I would go to the left 2 and up 5. 1, 2, 3, 4, 5. Here we go. And then to find another point that's on this, I first need to find the slope of this line and then determine the relationship between the two. Since it says it's parallel, that means the slope of the line that I'm trying to plot is going to be the same as the slope of this line. So let's find the slope of LB. Okay, so I'm doing the change in the y, so y2 minus y1. So on top I'd have 4 minus 2. And on the bottom, the change in x's, so -1 minus 2. And then simplify, 4 minus 2 is 2. -1 minus 2 is -3. So I could actually use this slope as is. This has a rise of 2, so that's up 2, and a run of -3. So that would be to the left 3. Now, given the point that I have here, if I try to go up 2, I'm actually going to fall off of the grid that I have to work with. So I'm going to manipulate this fraction a little bit. With a fraction, a negative can be either in the denominator in front or in the numerator, and that all means the same thing. So I'm going to move it to the numerator just so that I have my vertical change being negative, so I can move downward on my grid here. So from this point, I'm going to go down 2, and then the horizontal change is +3, so to the right 3, 1, 2, 3. Then I can do that again just so I can get more points to work with here. So down 2 and to the right 3. And if I went again, I would actually end up off of the grid that I have to work with here. So I'm going to go ahead and connect these dots. I kind of skipped a step there. I talked about it, but I didn't talk about it in the right place. So let me go back just a little bit here. The point that I plotted was the point that they told me is on the line. The slope I used was the slope of that I found from the line that was parallel. Because they're parallel, I know that the slopes are the same. So once I found this slope, I could use it with the point that I had already plotted. All right, our third guided practice problem here. This one says it's going to pass through the point 8, 5. So I'm going to go ahead and put that because that's a point on my graph. So I'm going to plot 8, 5. So from the origin to the right 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 5, 1, 2, 3, 4, 5. Here we go. So this is my point H. And this time it tells me that I want a line that contains that point and is perpendicular to this other line that they gave me. So I'm going to find the slope of this line. And then before I use that to plot it, I need to find the negative reciprocal of this slope. So here we go. The y2 minus the y1, change in the y's. So 2 minus 6 over the change in the x's. So that would be a -1 minus a -5. So on top, 2 minus 6 is -4. On the bottom, -1 minus a -5. That's the same as saying -1 plus 5. So that would be a +4. So my slope for line AG is -1. So that means the slope of the line that I'm trying to draw is going to be the negative reciprocal of -1. So negative reciprocal means it's going to have the opposite sign, so it'll be positive instead of negative. And the reciprocal of 1 is just 1 still. Now for graphing purposes, slope is better if it's a fraction. So I'm going to go ahead and put it as 1 over 1. So from this point, I'm going to make a vertical change of 1 and a horizontal change of 1, both in a positive direction. So that gives me a point here. And I could do that again from the new point. But I could also go back, and once again, I could put negatives with both the numerator and the denominator. And that would allow me to move the opposite direction on my grid here, so I can get more points even. So from my original point, vertical change -1, horizontal change -1. And you'll notice that it falls in line with the rest of the points that are there. So -1, -1, -1, -1. And I could do that all the way across the grid. Truthfully, we learned, though, early in this course that all you need in order to define a line is 2 points. And that's true on a graph as well. You could graph 2 points and connect them, and you'll have your line.